Good day to you, everyone. We are bringing a solution to the question you've seen on our screen um, of a charge, direction of a charge in I direction, I hat direction, J hat direction, and in K hat direction, which represent the X direction, the Y direction, and the Z direction. Um, the questions is on our screen, and the solution goes thus. Reading the question to determine what our parameters are. The question goes um, a charge Q1 is negative 20 microcoulombs, that is in a negative direction, is located at negative 6, positive 4, and positive 6 direction, which is I hat, J hat, and K hat, or XYZ. And a charge Q2, 60 microcoulombs, located at 5, 8, and negative 2 direction. The question has said that we should find the force exerted on Q2 by Q1 in vector form. Assumption that we have taken down our parameters. They said Q1 is equals to negative 20 microcoulombs. Then we have our Q2 to be 60 microcoulombs, and we represent our direction in L1 for Q1, which is minus 6, 4, 6. Then we have L2 for Q2, which is 5, 8, and minus 2. And we are said we should calculate the force exerted on Q2 by Q1. So we know this is an electric field. So it's dealing with charge, and that means we are going to be making use of the Coulomb's law. Now we have our F is equals to KQ1 Q2 over R square. That our K is our constant, and that's the value of 9 times 10 raised to power 9. Now, and we have our R, which is our distance in space. So, and the distance in space is not just a single distance. We have 3 more distance in different directions. We have in I direction, in J direction, and in Z direction. Likewise, which simply means in X, Y, Z direction. So we have things like this. We have a particular formula we used, and the formula is capital letter R, that is vector, then the modulus of the letter R again. This capital letter R simply means that it simply means the direction of the charge involved, that is the location of each charge, that is the location of charge 1 and the location of charge 2. Now the question is telling us that we should find the force exerted on Q2 by Q1, that is the direction of L2 from L1. So if we want to know the direction between these two, that means you are going to be subtracting the direction of L2 from L1. That's why we are having something like 5 minus, that is minus 6 at I hat plus 8 minus 4 J hat plus negative 2 minus 6 K hat. So when you minus it together, it's going to give us something like R in vector, that is 11 hat, 4 J hat, and minus 8 K hat. Now we have another thing which is known as the modulus of R. This modulus of R helps us to know the angle. It's also the criteria of knowing the angle of each direction of the charge. So if you know to know the modulus of the R, that means you are going to be squaring the direction you are having. That is the I hat direction, the J hat direction, and the negative 8 K hat direction. That's where we are having 11 square plus 14 square plus 8 square. When you take your 11 square, that's going to give us 121 plus 16 plus 64. Add everything together, you take the square root of it to give us something like 14.177. Now your R modulus is 14.177. Then don't forget, we have something we know as the R square. Then this R square is the radius, the square of the radius between the two charges. Then that means the modulus of R you have here, you are going to square it. That is going to give us 14.177 square to give us 201 meter. Now let's find the force exerted on Q2 by Q1 in vector form. Now in vector form, that is in I hat, in J hat, and in K hat. Let's take a look for the one in I hat. So if you look at the previous one we did, we have R vector in I hat, in 4 hat, and in K hat, which has the value of 11 hat plus 4 J hat minus 8 K hat over 14.177. So that is our vector, but we want to represent them in force, so we want to put them in I hat, in J hat, and in K hat. We put down our formulas: K, Q1, Q2 over R square. You can see by the left hand side you have something like 11 all over 14.177. That 11 is for I hat, and that 14.177 is the modulus of R vector. So for I hat, you are just only going to use 11. So you can see from the calculation we have 9 times 10 raised to the power 9 times negative 20 times 10 raised to the power minus 6 times 60 times 10 raised to the power minus 6 times 0.776. If you simplify 11 divided by 14.177, it's going to give us 0.776. So divided by 201, which is the square of the R modulus, that is 14.177 times 14.177. So our final answer is giving us negative 0.0416 I hat Newton. So where do you get this negative from? You get this negative from the negative 20 times 10 to the power minus 6 for Q1. So let's move. The same thing is applicable for the solution in J, force of solution in J hat. So we can have KQ1 over Q2 all over R square. Then we have for J, direction of J, that is 4. Then over 14.71772, which is our R modulus. There's mistake there. It's 14.177. Then you multiply, you simplify, then you have something like 20 all over 201. You still have your answer in negative 0.01516 G hat Newton. This negative comes due to the fact of negative 20 times 10 to the power minus 6. Then we move to our FK, which goes to us. Then our FK is having 8, which is negative 8 K hat all over 14.177. You simplify it. Once you simplify it and solve it the way we solved the previous one, you have answers to be positive 0.03032 K hat Newton. Where does this positive comes from? The positive comes from, we know that negative times negative, negative from 20 times 10 to the power minus 6, and negative from minus 8 all over 4.177 they are going to cancel each other to give us positive. Then our final answer is going to be Fn, that is the force in Newton. We have negative 0.0416 I hat, negative 0.015160 J hat, plus 0.03032 K hat, everything in Newton. This is the full solution. If you have any correction you want to correct us on, please let us know on the comment section or the comment box. Thank you.